All right, let's look at multiple linear regression. But in this case, we are going to be using simultaneous equation. Multiple linear regression is giving us, we have y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus dot dot dot. Then we can have beta n, that is a plus beta n s subscript n plus error term. Now it depends on the number of independent variable that is involved in the equation. Now this particular one will be considering two independent variable. So regression model with two independent variable will be y equals to beta naught plus beta 1 x subscript 1 plus beta 2 x subscript 2, then we have plus error term. Now we are not going to consider the error term now. So we have this regression model which is y equals to beta naught. The beta naught is a constant, or we call it that is a constant. We have beta 1 which is a coefficient, beta 2 which is a coefficient. So x1 and x2 are the two independent variables. So which means in this model we have three parameters: beta naught, beta 1 and beta 2. Then we have the dependent variable which is y. Now this y depend on the two independent variable involved here. Now we have different method. We have different method to form this model. We have formula method. We have matrices method. This is one of the method which is simultaneous. It's just a normal simultaneous equation in our regular mathematics. Now we're going to form other equations right from this particular model here, which is y equals to beta naught plus beta 1 x1 plus beta 2 x2. Now we are not considering the error term at this moment. Now the coefficient of beta naught here, we can assume it is 1, but what do we see? We multiply the whole of this equation here with n, since the beta naught does not have any variable. Beta 1 has variable which is x1, beta 2 has its own variable which is x2. So now we are going to multiply the main equation with n, and n is the summation. So since the n is coming to this variable, we cannot say yn, then we are going to use summation y equals to n beta naught plus, we have a variable here, we cannot use n, we use summation. Then we have a beta 1 summation x1 plus beta 2 summation x2. So we can tag this one equation 1. Now from the second parameter, which is beta 1 here, we have a variable here which is x1. So which means we are using summation x1 to multiply the whole of this equation here. So if you do that, we are going to have a summation x1 y equals to beta naught summation x1 plus beta 2 summation x1 square. This is going to be squaring because we have summation x1 here already, and we are multiplying each by summation x1. Therefore, we have summation x1 square, then plus, sorry, rather, this is beta 1 plus beta 2 summation x1 x2. So we tag this as the second equation, that is equation 2. Then the third parameter, which is beta 2, acts variable which is x subscript 2. So we multiply summation x subscript 2 with all of this main equation here, and that gives us summation x2y equals to beta naught summation x2, then summation x2 multiplied by x1, that is going to be plus beta 1 summation x1 x2 plus, we're using summation x2 to multiply x2 here, that will give us beta 2 summation x2 raised to power 2. So we have equation 3 here. So these are the three equations. And why do I have three equations here? Because we have three parameters, which is beta naught, beta 1, beta 2. If you have two parameters, we're able to form two equations. And if you have four parameters, we're able to form four equations. So on ground now, we have 1, 2, 3, which is three equations. Now, although this particular equation here, there is a way you can use matrices method to handle it, but we are not considering that here now. All right, let's consider this table. We have say we have a y, x1, that's too big, x2, so assuming we have value of y to be 1, 2, 3, 5, 6. Then we have x2. Let's say x2 we have 2, 4, 5, 8, 9. And the value for x2 to be 5, 9, 13, 14, and 17. Now, from these three equations, we need all this summation. The first one here, we have n. N is the number of observation, and in all of these, our n we have 1, 2, 3, 4, 5. So which means each variable contains 5. Each variable contains 5 rows. So we have 5, comma, then summation y. We'll be needing summation y from here. If you add all of this together, 1 plus 2 plus 3 plus 5 plus 6, that will give us 17, comma. We need a summation x1. Summation x1. So if you add all of this column together, 2 plus 4 plus 5 plus 8 plus 9, that will give us 28, comma, summation x2 equals to, we add all of this together, 5 plus 9 plus 13 plus 14 plus 17, that will give us 58. That is a 58. All right, we also need, from here, we need summation x1y. So we need to form another column here to get x1y. So which means we are to multiply each value in the column x to the corresponding value of column y. So here we have 1 times 2, that's a 2. This 2 multiplied by 4, 8. This multiplied by this, 15. This multiplied by this, we have a 40. 6 multiplied by 9, that's a 54. So summation x1y equals to, if you add all of this column together, 2 plus 8 plus 15 plus 40 plus 54, that will give us 119. That is 119. Now, we're using the second equation now. Summation x1, we already have it here. We have x1 here. So we need x1 squared. We form another column from x1 squared. As each value in this column, we're going to square it. So 2 squared will give us 4. 4 squared, 16. 5 squared, that is 25. Then we have 8 squared, 64. 9 squared, that is 81. So if you add all the value in this column together, that is 4 plus 16 plus 25 plus 64 plus 81. Therefore, we have summation x1 square. Then that is going to give us 190. 190. We're still dealing with equation 2, so we need x1, x2. So x1, x2. We have to multiply these two independent variables correspondingly. So we have 2 multiplied by 5, that will be 10. 4 times 9, we have 36. This multiplied by this, we have 65. Then this value multiplied by this value, we have 112, 112. And lastly, 19 multiplied by this will give us 153. So summing all of this together, 10 plus 36 plus 65 plus 112 plus 153. So we're going to have a summation x1, x2, summation x1, x2 will be 376. We have 376. Now moving forward, this is equation 3. In equation 3, we need x2y. x2y. We have to multiply this column by this column. So we have 1 times this value, we have 5. This multiplied by this. Now this multiplied by this will be 18. Then the next one we have 39. The next one we have 70. Then the next one we have 102, and that is 6 multiplied by 17. So we have 102. Adding all of this together, summation together, we have summation x2y to be equals to, if you add all of this together now, that is going to give us 234. 234. Then summation x2, we already have x2 here. x1, x2, we already have x1, x2. Then we need x2 square. That is the last column we need here. x2 square. So each value in this column, we're going to square it. So we have 5 square, and that is 25. Then 9 square, that is 81. 13 square, 169. 14 square, 196. Then we have 17 square, that's 289. So we have summation x2 raised to power 2 will be equals to, if I add all of this up together, we are going to have 760. 760. All right, now. So we'll come back to the 3 equations that we formed earlier, and substitute each summation into the equation. So instead of summation y now, our summation y from here is 17. So we have 17 equals to, then we have n, which is 5. So we have 5 beta naught plus summation x1. Summation x1 is 28. So we have 28 beta 1 plus, then the next one we have summation x2. Summation x2 from here, we have 58. Then we have 58 beta 2, equation 1. For equation 2 now, we have summation x1y. Summation x1y is 119. So we have 119 equals to summation x1, which is 28. So this we're going to have 28 beta naught plus summation x1 square. Summation x1 square is 190. We have 190 beta 1 plus summation x1 x2. x1 x2 is 376. So we have 376 beta 2. This is equation 2. Then the last equation is summation x2y. This is x2y 234 equals to, then summation x2. Summation x2 is going to be 58. So we have a 58 beta naught plus x1 x2. We have x1 x2 to be 376. 376 beta 1, then plus x2 square. Our x2 square, we have 760. So we have 760 beta 2. So this is equation 3. So these are the three equations that we need for the simultaneous equation in order to get the parameters, the three parameters, the beta naught, beta 1, and beta 2. Now, if you look at these three equations very well, if you're doing the writing, the first, let's ignore this side. Now, we want to handle the right-hand side. Now, what do we do now? So, if you notice, we have 5 beta naught, 28 beta 1, 58 beta 2. The coefficient of each parameters here more correspond with the coefficient of beta naught. That is the coefficient of constant in each equation. This is 528, 58. This is 528, 58. If you're doing the right thing, you should have something similar to this. Then 2, apart from this diagonal, let me just you can see this is the diagonal. So if you remove this diagonal now, every other value appear twice. This is 28, this is 28. This is 58, this is 58. We have 376, then we have 376 here. If you do not have it this way, that means you are doing something very, very wrong. So if you have something similar to this, that means you're on the right path, and it will be nice if you pay attention to the calculation. All right. So from here we move. We want to handle. We are using elimination method. In equation like this, we can either use elimination method or substitution method. But this morning we'll be considering the elimination method against substitution method. Now, let's consider equation 1 and 2, because we need to eliminate some of these parameters so that we can get other parameters. We're having 3 parameters here. If we do not eliminate, there's no way we can get other parameters. So now I want to consider equation 1 and equation 2. So we want to eliminate beta naught in equation 1 and equation 2. And what do we do? Now, this is it. This is equation 1, equation 2. The coefficient of beta naught in equation 2, we're going to use it to multiply the whole of equation 1. And the coefficient of beta naught in equation 1, we're going to use it to multiply the whole of equation 2. So the coefficient of beta naught in equation 2, which is beta naught here, we are considering this equation 1 and 2. So the coefficient of beta naught is 28. So which means we are going to use 28 to multiply the whole of this equation 1. So now 28 multiplied by 17, that will give us 476 equals to 28 multiplied by 5. That will be 140 beta naught plus 28 multiplied by 28. That was 784 beta 1. Then we're going to say 28 multiplied by 28 multiplied by 58. 28 multiplied by 58, that will be 1624, 1624, 1624 beta 2. So we can name this one to be equation 4. Now, the coefficient of beta naught in equation 1, we are going to use it to multiply the whole of equation 2. So 119 multiplied by 5. 119 multiplied by 5 will give us 595. 595. Then 5 multiplied by, so we are using this beta naught to multiply this now. So 5 multiplied by 119 give us 595. Now 5 multiplied by 28 will give us 140 beta naught. The coefficient of beta naught has to be the same so that it will eliminate beta naught completely. Then we have plus 5 multiplied by 190, that is 950 beta 1, plus 5 multiplied by 376, that should be 1880 beta 2. So let's say this is equation 5. Now we can subtract equation 4 from equation 5 or equation 5 from equation 4, anyone you prefer. So if we have 476 minus 595, that will be minus 119 equals to 140 minus 140, that is definitely 0. Then we have a minus 784 minus 954, that will give us negative value. That's why we have negative result here. So 784 minus 950, that should be 166 beta 1. Then 1624 minus 1880, that will give us minus 256 beta 2. So this negative here will eliminate all the negative. Therefore, we just have 119 equals to 166 beta 1 plus 256 beta 2. So let's say this is equation 6. You can see from this equation 6 now we are left with just two parameters. We've eliminated beta naught, so we only have beta 1 and beta 2. So now again, we'd like to consider equation 1 and equation 3. We want to consider equation 1 and equation 3, and what we want to do here, we just want to eliminate the beta naught so that beta naught will move out completely from the equation. If you have two equations left, that will be much easier for us to get one of the parameters. Now, the coefficient of beta naught in equation 3 is 58. We're going to use it to multiply the whole of equation 1. So which means 58 multiplied by each value here, or coefficient of the parameters here. So if you do that, we have 58 multiplied by 17, that will give us 986 equals to 58 multiplied by 5, that should be 290 beta naught plus 58 multiplied by 28. 58 multiplied by 28, that should be 780. 58 multiplied by 28, that is 1624 beta 1 plus 58 multiplied by 58, that is 3364 beta 2. So let's say this is equation 7. equation 7. Now, the coefficient of beta naught in equation 1, we're going to use to multiply the whole of equation 3. So which means we're using 5 to multiply the whole of equation 3. And if we do that, we say 5 multiplied by 234. That will give us 1170 equals to 5 multiplied by 58. That will be 290 beta naught, then plus 5 multiplied by 376. That will be 1880 beta 1 plus 5 multiplied by 760. 5 multiplied by 760 will give us 3800 beta 2. So we say this is equation 8. So if we subtract equation 8 from equation 7, or we subtract equation 7 from equation 8, and how you do it, we're going to have 1170 minus 986, that will be 184, equals to, this will definitely give us 0, so it is eliminated. 1880 minus 1624, that will be 256 beta 1 plus 3800 minus 3364, that will be 436 beta 2. So this is equation 9. Now from equation 6 and equation 9, beta naught is eliminated completely. So we are going to consider equation 6 and equation 9 in order to eliminate one of these parameters. It is that we eliminate beta 1 or we eliminate beta 2. Any one of each will give us what we want. Now, let me write equation 9. So we have 119 equals to 166 beta 1 plus 256 beta 2. We have this as equation 6 from the previous workings, and we also have this as equation 9, which is 184 equals to 256 beta 1 plus 436 beta 2, equation 9. So we want to work on equation 6 and equation 9 now. So if we intend to eliminate beta 1, so it means the coefficient of beta 1 in equation 2, we are going to use it to multiply the whole of equation 6. So which is multiplied by 256. Then this multiplied by the coefficient of beta 1 in equation 1, 166. So if we multiply 256 by all of these values, then we're going to have 30464 equals to, this multiplied by this will give us 4249 beta 1 plus 256 multiplied by 256, that will be 65536 beta 2. We can name this to be equation 10. Now 166 multiplied by each value here, so this is I think we are going to have 166 multiplied by 184, that should be 30544 equals to this multiplied by this. We have a 42496 beta 1 plus this multiplied by this. Now we have 72376 beta 2. This equation 11. If you subtract 6 from 11, that is, we minus this now, subtract that, we have 30544 minus this, so we're going to have an that should give us 80 equals to this minus this cancel each other. Then we have 72376b2 minus 6556b0. So that will give us 6840 beta 2. If you make beta 2 the coefficient, the subject here, we're going to have beta 2 to be equals to 80 divided by 6840, and definitely this is going to give us 0.0117. That is, if you approximate it to 4 decimal points rather. So we have the value of beta naught to be 0.117. Now that we have the value of beta naught, we already know the value of beta naught, we can now substitute this value to either equation 6 or equation 9 here. So let's substitute 0.0117 for beta 2 in equation 6 rather. So if you substitute that value into equation 6, so we're going to have 119 equals to 166 beta 1 plus 256 instead of beta 2, then we substitute 0.0117. Now if you do this, we have 119 equals to 166 beta 1 plus, if you multiply this 256 by 0.0117, that is going to give us 2.9952. So if you take this out, that is a 119 minus 2.9952, that is going to be 116.0048 equals to 166 beta 1. Making beta 1 the subject, we're going to have beta 1 equals to 116.0048 divided by 166. So if you divide this and we leave the answer in 4 decimal place, this is definitely going to give us 0.69882. So we have 0.69882. So we can remove these 2 here since we are considering 4 decimal point. We have 0.6988. We approximate this to 0. Now the value of beta 2 is known. The value of beta 1 2 is known. So we need beta naught. We need to find the value of beta naught. And from the main equation 1, we have 17. This is equation 1, equation 2, equation 3. We can use any of these 3 equations to find beta naught. Beta 1 is known, beta 2 is known. The only thing we need here now is beta naught. So we can use any of this equation to find the beta naught. So let's consider equation 1, so which is 17. So equation 1 remains 17 equals to 5 beta naught plus 28 beta 1 plus 58 beta 2. So now if you substitute the value of beta naught and beta 1 into the equation, so we have a 17 should be equals to 5 beta naught plus 28 into bracket beta 1. Beta 1 is 0.6988. We have 0.6988 plus 58 beta 2. We have beta to be 0.0117. 0.0117. All right, if you open this up, we're going to have 17 to be equals to 5 beta naught. We have 5 beta naught. 28 multiplied by 0.6988. We're going to have 19.5664. Then we have a plus 58 multiplied by 0.0117. So that will give us 0.6786. So we take all this value outside here. We have 17 minus 19.5664 minus 0.6786. So if you calculate it that way, that would definitely give us a negative value, which is minus 3.2450 to be equals to 5 beta naught. Making beta naught the subject, we're going to have beta naught equals to minus 3.245 divided by 5, and this will give us a negative result, which is minus 0.649. So this is the value of beta naught. Now the value of the 3 parameter is known. This is the value of beta naught, beta 1, and beta 2. Now going back to the model, for 2 independent variables, we have y to be beta naught plus beta 1 x1 plus beta 2 x2. So if you substitute each value of the parameters into the model, therefore we have y to be equals to beta naught. So we have minus 0.649 plus beta 1, we have 0.6988 x1 plus beta 2, we have 0.0117 x2. So this is the model for the value given for 2 independent variables.